Fantastic, great. Okay, well, hi everyone. Welcome to my workshop. I've always wanted to do a workshop on do it, twist it, solve it. Something I've been working on for 5-6 years now, and I know those words are bandied about quite a lot on Twitter and in the maths community. And I'm just very passionate about the lesson design to support children to secure and deepen their understanding of mathematics. I'm going to do what I can in this sort of 50-55 minutes. I'm on Twitter at MaxTheMaths, and the pinned tweet on my Twitter is actually a link to a blog about this. So if there's some little bits that either I gloss over too quickly or you're not sure about, then hopefully I've covered it in the blog that you can find from the link there. Who am I? I mean, well, I'm MaxTheMaths. I work at a teaching school in Cheltenham in Gloucestershire. Part of that is leading the Maths Hub there, and that links me to the NCTM. I'm also accredited PD lead for the NCTM. But really, my passion and a lot of my time lies in Kangaroo Maths and Can Do Maths. Two websites, co-founded the first one with my good buddy Matt Nixon, and the other one with my good buddy Liz Hopkins, and I'll talk about those later. But they're just places where I dump stuff to share with colleagues, and you can also see there a little cheeky Ready Set Go advert there. I've been working with the Just Maths guys as well, and we'll talk about that later maybe. But that's me. That's me. I've just been doing this gig for a long time now, working with primary and secondary colleagues, looking at teaching and learning of mathematics. What I want to cover in this workshop, and I guess what I'm quite passionate about, is and everything we do really is always, isn't it, about the principles of this. So do it, twist it, solve it, do it, bop it, zap it, do it, kick it, whack it. These words, they could be any words. What is important? What are the principles of this design? What are those 3 words trying to get behind? Why is it a useful lesson design? So I want to just do a bit of the journey, the origins of this, the principles of it, and then just a couple of examples. One from Key Stage 2, one from Key Stage 3, as in the mathematics, but it could be worked in both key stages. I'm mindful the audience may be cross-phase for this workshop. And that's really important for me, actually. The do it, twist it, solve it, do it, secure it, deepen it model works from year 1 all the way up to post 16. And he's working, and yeah, it's good. Apart from the other thing I do want to talk about, some caution actually, because I also do get some feedback going, it doesn't work, Steve. And the other caution, by the way, of course, is this is not a formulaic, every lesson must look like this. What I'm also very passionate about is this is a good lesson design to secure and deepen understanding for a typical maths lesson. But of course, within a sequence of learning over a unit of work, not every single lesson is going to look like this. And I feel that's really important. We don't get too formulaic here. But that's why I want to keep talking about the principles of what we're trying to do. So let's just do the origins, if that's okay. I mean, this did start 5-6 years ago. I had the great privilege of going to Shanghai. I'm not sure if the S word's allowed these days to mention it, but that's where it started. The Shanghai was about a teacher exchange, and that's what I got from it. I was just working with colleagues from another culture, talking about how do you design lessons. And I've put this up because then when they came over to this country and just we carried on that conversation, this was really interesting. You know, the careful choice. What do they want the students to notice? So this was simply a unit fraction lesson, and you might be looking at it going, well, that's nothing special. Apart from, and we'll touch on this, that maybe those, I'm going to call those first 2 the standard examples we may want to use. And then really, if I just want to push the understanding a little bit more, can you still see the equal parts on that next one? Oh, yeah, I can see 4 equal parts and one of them is shaded. And if we're into pizzas, you know, my goodness, when was the last time you saw a pentagonal pizza? Fractions does not equal pizzas. So the children are actually just seeing non-standard, shall we say, representations of fractions. And I was quite excited by this point, thinking, wow, they really know what a unit fraction was. The teacher wasn't happy because they wanted to just, do you really understand? And what struck me straight from the word go, whereas I was probably going, hey, that's great, they can do this, they can do it, there's the word, they weren't happy. They were saying, go on, and if you do understand this, convince me. Let's see you do truly understand this concept we're talking about today. And I'll just let you just have a look at those three diagrams for a moment. Just to, really the question is, why has the teacher chosen those for? What is the teacher trying to expose? What are they trying to secure, maybe, in the understanding of the learner? Now, of course, you know, it's interesting as well, by the way, isn't it? It's no longer about the student giving me the answer. It's now about saying, here's the answer. Do you agree? Here's the answer. It's wrong. Tell me why. And so obviously the first two are there to say, well, equal parts. That's a really important part of this concept. The third one, though, they are equal. So that's been chosen for a different reason. I can definitely see one orange triangle. I can see three white triangles. So 1/3 seems okay. But oh, no, that's not 1/3, is it? It's 1/4. It's one of 4 equal parts. So saying the concepts, and by the way, that's something that I was really noticed as well, the language. I want you to speak like a mathematician. I know my good buddy Tom Manners talks about that. You know, and there's a big thing at Balcarras Teaching School where I work, this idea that I want language being used. So don't tell me it's wrong because it should be 1/4. Tell me it's incorrect because it is not one of 3 equal parts. Talk to me about the concept. The last one was interesting because if they pattern spotters in the class, they're going, oh, that one's wrong, that one's wrong, that one's wrong, this one must be wrong. So they also chuck in that little surprise, going, no, but it's still a non-standard because, you know, we don't always do the diagonal cut. So that was a lesson I saw for lower key stage 2, upper key stage 2, lower key stage 3, and then we had another one with a secondary teacher, and does this work in upper secondary? And this was just a little snippet of a lesson that I observed, and the question was this, and the question was actually, I'm going to do it for you, and you tell me. And what anecdotally, I was really interested in with this question. This was with top set year 10 in a high performing school, and they were, well, our students know how to solve a quadratic. Of course they do. So the teacher did this. They said, okay, I know we have to factorize, so I'm going to factorize the quadratic. I know that those 2 brackets must multiply together to make the number. So 2 numbers that make 2 are 1 and 2. So the first bracket equals 1 and the second bracket equals 2. Oh, actually, wait a minute. I could let the first bracket equal 2 or the second bracket equal 1. Now, if I solve those, I'm going to get that one value for x is 3, the other x is 5. On the right-hand side, I could solve it and actually get 4 in both those cases. Hey, you know what? So I've now found that x equals 3, 4, or 5. And everyone was nodding. The students were nodding. And the teacher said, do you agree? Now, this is a class who said they understand quadratics. They know there's at most 2 solutions to that quadratic, yet they were happy. So the deliberate use of a mistake, a misconception to challenge their understanding was a real light bulb moment for me. And I guess that links with a lot of the work I've been involved with the secondary teaching for mastery, in terms of, you know, really thinking carefully about when we present a collection of examples or exercises. What do we want them to look for? What do we want them to pay attention to? Am I just giving you a random set of questions, or have I deliberately picked question 3? Now, there's another word of caution here because, you know, obviously this isn't breaking news, and a lot of people have been working on this, and variation theories come into being trendy now and so on. And this was interesting from talking to some of the mastery specialists, that actually minimally, minimal varying the question. I want you to notice, children, careful what you do here. Actually, when at the end of this lesson, when the students were asked, what do you know about quadratics? They said they always end in 24. So actually, they didn't understand the structure of how to factorize a quadratic. They were pattern spotting. They were pattern sniffing. So we've got to be really careful. Even though we pay careful attention, if we go too minimal, then actually that could go off in a different route and lead to other misunderstandings. So I guess I've mentioned the M word. And I think it's important at this point, because do it, twist it, solve it is my way of actually saying, well, the M word's being used in lots of different ways now. I am absolutely passionate about how do we make sure children have a secure and deep understanding. Students really do understand their mathematics. And so actually this is a lesson design, do it, twist it, solve it, which is trying to say, hey, great, you can do it. Are you secure? How deep is your understanding? So it's just a way of thinking about how can I, if you like, package the tasks to do that job. A little quote from Desmond Tutu. He talks about mastery. I don't know if you know that. I'm joking. It fits with, obviously, I love this quote because it does fit with what do it, twist it, solve it's trying to do. At every point of the journey, we want children to make sure that they are secure. So therefore we can build on that for the next stage of the learning. It's sustainable. So actually we don't get to the end of year 6, the end of year 11, and we're having to do all sorts of interventions and revision programs because the rules they're taught have either been forgotten or no longer working. So let's make sure that every bit of the journey we've got secure understanding and deep if we can. But I'm really quite obsessed actually making sure students have got a secure understanding of today's learning. And at the same time, the assessment changed. Key Stage 1, Key Stage 2 SATs changed, National Curriculum Test, the GCSE changed the last few years. Here's an example from Key Stage 1. And it's really interesting, isn't it, that the standard pentagon, the one that I pick out of the shape set, isn't there. So that's really beginning to expose, do you understand what a pentagon is? At Key Stage 2, a similar question. Which one's a pentagon and which one's got 4 acute angles? So that changed. That GCSE, you got questions like this creeping in, which I think is great. It's about, do you understand? And I know some students grappled with this one and really found it hard because they hadn't met a quadratic that could not be factorized. So back to that, what experience have they had? What mathematics are they exposed to? Then this was hard. I mean, I love this. This was the response to this on Twitter. Without expanding brackets, show how you get exact solutions. Do something. What do you notice? What are you paying attention to? It was really funny. On Twitter, you got responses like this. What do you mean, don't expand the brackets? I've been doing that for 3 years now. Now you can't do it. They've had a very procedural, I guess Charlie's had a very procedural experience of mathematics. Connor, let's poor old Connor. That question really then said, cool, do you really understand how to solve that equation? This looks a really dry question, and I'll just pause here. Just have a little go for yourself, and as you're doing it, I want you to think about, if a student wasn't successful with this question, what was it? What was the moment? Now I'll let you keep playing with it, and I'm just mindful of, make sure we get everything done within the time we have available. Now, obviously, you're substituting in at the moment. You're expanding a bracket out there. You've got a quadratic. You're going to lead to solving that quadratic. And what was interesting when you read the examiner's report, that substitution was on the whole fine. And what was interesting for me was that, there was maybe that little misunderstanding, but again, we know that happens, that when I square a binomial, that actually do I get all the terms I should do? That, for example, would be a good twist it for me. Steve thinks that. Do you agree? And then I want the students to tell me. But the big barrier was that some students got a quadratic equal to 25 and then just tried to solve it. They didn't understand why they must make it equal to 0 before they can then factorize. Goes back to the lesson I saw from the Shanghai teacher who wanted to draw the students' attention to that fact. So if they've just done lots and lots and lots and lots and lots of solving, give me the answer, give me the answer, give me the answer, then when they met this non-standard one, the wheels came off. So their understanding wasn't secure. So let's talk about those principles a bit more then. I'm obsessed with principles, by the way. I've been described as the Mary Berry of maths, which is, I don't know if that's a good thing or a bad thing. But the reason why, and the reason why I want to talk about principles is because if you like, do it, twist it, solve it, bop it, zap it, kick it, whatever word you want to use, could become a recipe. Oh, right, that's when we do our reasoning. That's when we do our problem solving. That's when we do there. And the problem is then the recipe people start going, well, we'll take that bit out of the recipe. We'll do this bit. And rather than getting that beautiful Victoria sandwich, we end up with a cake that's not quite what the intention is, because some of the principles of the basic recipe have not been respected. And that's why I'm absolutely obsessed with this workshop, to really focus on those principles. And then we'll talk about how we put it into action. So to try and demonstrate the principles, some of the key things that I hold on to, I've talked about pentagons earlier. So here again, here's a little moment for you again. Just draw yourself a pentagon. See how secure your understanding is of a pentagon. Draw yourself another one. Draw another one. So John Mason, show me another, show me another. Show me one that no one else will draw or make. So over to you. Just I want you to just doodle now on the sides. Hopefully you've done 4 pentagons. Hopefully you know more than 4 pentagons. But again, think about those key stage 1 and 2 questions. Some students actually may have only ever met 1 pentagon, the regular one, because that's the only one they've experienced. Now, I've just used a geo board thanks to MathSpot. Just to demonstrate. I'm guessing you've drawn some of these things, and I know students who will say, "Oh, I've drawn a house," and I'm not interested. Tell me why it's a pentagon. Convince me. And I usually get, "Yo, there's another one. Tell me." And they go, "It's got 5 sides. It's got 5 sides." That's right. It's got 5 sides. Well done. I could at this point be very happy. They know what a pentagon is. They can do lots of different pentagons. So what's the next step to go to then? Is to say, okay, do you really understand what a pentagon is? So here we go then. A principle here is that you've given me lots of answers. The answer is only the beginning. That's a really important mantra for me. Yes, you've got the answer. Tell me more. Convince me. So, yep, you've given me the answer. Okay, 5 sides. Here we go. 1, 2, 3, 4, 5. Pentagon. Over to you. Just argue with yourself. Obviously, if we were doing it face to face, we'd have a bit of a vote right now. Is that a pentagon? Is that not a pentagon? And if you're saying it is, convince me. And if you're saying it's not, why? And maybe then the people who've said, oh, it's 5 sides, are now all of a sudden saying, oh, it's got 5 straight sides. They're being more precise now. So that convince me is becoming more precise with the language and the terminology. It's not a pentagon. Of course it's not a pentagon. It's a what it's not. It's a non-example of a pentagon. So examples and non-examples. Do it, twist it. Examples, non-examples. So some of the principles here, I'm interested in what the thing is today, what it is, what it's also, but I'm also passionate about what it's not. And for me, that's the secure moment. If you can tell me why something is not, and you use the right language, and the response is not because it should be this, but it's about the concept, they're not equal parts, they're not straight sides, then I think we can say, I think you do have a secure understanding of this. I use this a lot, trapezium. I mean, when I was at school, the reason I use this, I remember the lesson where I was just taught loads of quadrilaterals. And so I knew the top right-hand one was a trapezium because, well, it's like the trapeze artist at a circus. Shocking. But I do remember, that's what my teacher said. So how many are there? Are there 5, 4, 3, 2, 1, 0? Why can't the bottom right one be a trapezium? It's got a pair of parallel sides. Oh, it hasn't got 4 sides. So we're getting to unpick what is a trapezium. Can a trapezium have a right angle, bottom left? I know plenty of students who say that's not a trapezium because a trapezium has to have that shape to it, the scalene, if you like, version. So we now get into the, oh, it's exactly one pair of sides. So on that slide, I've got some examples of what it is, what it's also. I've also got some what it's not going on there. So this what it is, what it's also. Let's do another example. You know, what it is, well, Pythagoras. We see plenty of those ones, don't we? I know plenty of students who can do that. I might be clever, they might want to just represent it that way. And they're still really good at finding the missing side using Pythagoras. Why? Because it's the standard triangle, what it is. It's the diagonal, it's the sloping side, using the language of students. So then when they're presented with what it's also, the third example, the wheels come off some students. Because they're not actually talking about Pythagoras' theorem. They're just saying some sort of rule. The sloping side squared equals the sum of the other sides squared. They don't understand it. So where would what it's not fit into Pythagoras? Well, let's hit that head on. Let's use a triangle like that. Let's get the formula off the post on the wall. A squared plus B squared is C squared. Let's stick some numbers in and say, there you go. There's my answer, students. And the question is, do you agree? But actually, one of the principles I want to talk about, I'm actually coming away from the do you agree now, and I'm actually moving more into saying, this is incorrect. Tell me why it's incorrect. That's what's important. And I want you to use the language that's correct, the language that I've modeled in my teaching, that we've talked about in class. So this incorrect. And lo and behold, there it was, a GCSE question. Sanita made the same mistake. I'm not doing this today, by the way, to go, oh, because of the exam question, we need to do this. It's just nice to see that these questions are now saying, do you understand? The Shanghai teacher interprets that as saying, I've planned my lesson, I've taught it, you've learned about Pythagoras, but they have this lovely little word to say, my job is now to try and confuse you. And that's the bump in the road that I like, the what it's not. That's the twist. The twist is not just it looks different. The twist is putting a bump in the road to say, do you really understand this? So what it is, what it's also, what it's not. There's a fourth what for me, which is really important. What problems can I now solve? For me, they're the four things I hang on to design my lesson. And so we know questions like beautiful open middle stuff. We know where there's a problem here, we have to apply what I've just learned to it. So it's an unfamiliar context. Those fit beautifully. They're now problems to solve. Solve it. Go on, off you go, solve it. So I'm just packaging, as I said earlier. All right, there you go there now. And maybe if you can solve those, you're beginning to show me a deeper understanding than if you were just doing some questions and giving me the answer. I've talked about bumps in the road there. That's a thing that quite a few folk are now talking about. Maybe away from that, do it, twist it, solve it. How do I challenge? Let's talk about differentiation. How do I challenge my students? I put a little bump in the road, what it's also. I put a larger bump in the road, what it's not, and tell me why it's not that. I put an even larger bump in the road by some problems to solve that you have to do independently, apply your understanding to. This isn't breaking news, of course, this idea of bumps in the road. And I think back to principles, it maybe explains some of the reasons why students have not been successful in the past with GCSE, with their national curriculum tests, because maybe they've had a very smooth path. And I'm saying that on purpose, Because there's this article from 1992 from ATM, from Alan Wigley, which is exactly this. What do we want to do? Do we want to smooth the path for students? Now, for me, the danger of those minimally different questions I showed earlier, where the quadratic was 24, there's a danger we're smoothing the path there. And actually, the student left that lesson feeling good for those particular questions they could do and were given to do. It didn't mean they understood the structure of it. So actually, this idea of if I don't understand it, then learners will flounder when presented with unfamiliar problems, goes back to the GCSE question whether quadratic equals 25, because they'd had such a nice journey, always equals 0, so I can always solve it, and then they couldn't. So that article really resonates with me, and that do it, twist it, solve it model is trying in a way to achieve this. Let's put some bumps in the road to see if you understand the mathematics. I mentioned Can Do Maths earlier. One thing we do on Can Do Maths, we have these things called Maths Mastery Matrix, MMM, and you'll notice on the left-hand side what it is, what it's also, what it's not, and what problems can I solve. And if you look at that middle row there, everything is saying, this is incorrect, tell me why. This is incorrect, tell me why. And the idea is that the student explains using the language. 1 is not a prime number because it does not have exactly 2 factors. You know, here's one, you can see the same thing. I'm just trying to show fractions. But even if you look at the top row, oh, wow, well, wait a minute. Sometimes we've got 3 fractions that are being subtracted. 2 fractions from a third fraction. And so what it's also can just be, it's represented in a different way. You'll see there that the first one, Colin, he thinks that 5/8 take away 3/5 is 2/3 because you take away the tops, you take away the bottoms. Sloppy language. But if we don't expose that and then get the response to say, no, you can't do that because the denominators are not equal, then that doesn't, I don't think the students necessarily do fully understand. You'll also notice along the bottom, there's some classic kind of ways to deepen understanding. Let the answer's this, so what's the question? Always, sometimes, never. Empty box, like the open middle type questions. Really say, come on, do you understand this? Here's a problem to solve. So there's a whole collection of those. If you're interested, get in touch about Can Do Maths. It's amazing. I would say that. Kangaroo Maths, same sort of thing. Matt and I are playing with this, that the you know, for each of the key learning points in Kangaroo Maths, this is something that we're working on at the moment and we'll be sharing, where I'll give you some examples of what sort of do it questions. Give me the answer, student. Give me the answer. Give me the answer. The twist it will well, the twist it is, it's incorrect. Kenny thinks 30 is a common factor of 6 and 15. Yeah, that sounds good. 6 and 15 both go into 30. Why is he incorrect? Well, he's incorrect because that's a multiple. It's not a factor. Deepen it has got a problem to solve. I'm not going to tell you how to solve it. Over to you. It's got an always, sometimes, never type question. It's got empty box type questions. And by the way, those empty boxes are huge. You know, the idea, I can solve it one way. I can solve it another way. I can solve it in many ways. But actually, then I might tell you, you can only use the digits 0 to 9 once and once only. So you've got to solve all 3 statements together. That becomes challenging. So actually, one question, many solutions, one problem, many solutions, is now a nice way to challenge my understanding. Go deeper rather than accelerate onto new content. What I've shared there, you know, a bit of cheese for you. Cheesy acronym, depth. If I'm interested in depth of understanding, then they're the 5 things I'm talking about. They're the 5 things that then form, if you like, the twist it and solve it part of my lesson. That I want an explicit use of misconceptions. Of course, by the way, and this is really important for me, I deliberately put a misconception, a mistake in the twist it in the second phase. But of course, if it comes up in conversation or another one's come up, then we talk about that. It's not the only place for misconceptions to be discussed, misunderstandings, but it's definitely a place where we will address them. Missing digits, here's the answer, what's the question? So that's a really useful sort of, you know, teacher toolkit kind of thing about some strategies that work for any bit of mathematics. So let's talk about examples. So let's put this into practice, and it kind of links with the caution bit as well, I guess. Let's pause. I've talked an awful lot there. I'm going to do a lesson which is about adding fractions on the left-hand side. The right-hand side, I'm going to do a lesson about multiplying a single term over a bracket. So I'll just pause. I want you to think about what are we trying to make sure students are secure about? What is it? What's the understanding I want them to get from that lesson? So, I guess what you're thinking to yourselves now is actually, do you have students who do that? They say, oh, 2 terms. I want to make sure that students leave the room knowing the answer to that is 2/5. And I'm talking year 3 here. I'm talking about, and I'm saying year 3 in terms of the program of study. And I think this is something that I'm going to talk a bit more about in a moment about. We've got to be really careful, aren't we? If my lesson is just about adding fractions, well, we could, adding fractions could be a 5-year journey if we wanted it. It could be even more than that. Am I talking about algebraic fractions? Am I talking about fractions with the same denominator? Am I talking about fractions with denominators that are multiples of each other? Am I talking about fractions with denominators that are not multiples of each other? Am I talking about a negative solution? Am I talking about a mixed number, improper and proper fraction? So this is definitely a lesson where it's actually saying, okay, let's think about how do we add fractions with the same denominator? Likewise, on the right-hand side, is it just me, or do you have some students who say, oh yeah, it's 3q add 6, and they forget to multiply the second term inside the bracket, or the other terms, let's call it, inside the bracket, so they don't give that answer. So straight away I'm thinking, right, it's almost they've populated my twist it already. I'm going to give them that and say, tell me why it's wrong, please. And that's the point of it. I want to secure. I don't want anyone leaving the classroom thinking it could be that red one. It can't be. And let's talk about why. So in terms of the question, let's talk about that for the moment. Obviously the do it then, hopefully what I've established by this point, do it is about, here's a question, give me the answer. Here's a question, give me the answer. Here's a question, give me the answer. And so the first 2 on the left-hand side there, you're not getting too excited, and that's fine. Bottom right, okay, we're beginning to put some little bumps in the road, because I know students who, if they've only been given 2 fractions to add together, they'll freak out. I've got 3, I can't add 3 fractions together. So that's adding fractions with the same denominator. What do I want to, what's the next bump in the road? What do I want to make sure, what do I want to secure, is that no one thinks Colin is correct. And that's why I'm not going to say, do you agree with Colin? I'm telling you, he's incorrect, guys. Tell me why he's wrong. And I don't want them to say he's wrong because the answer should be 2/5. What I want them to say is he's wrong because he's added the numerators and the denominators, and you can't add the denominators. Talk about the concept. How do I go deeper? How do I give you some problems to solve? Well, the answer is 12/15. So over to you. Give me 2 fractions that add together to make 12/15. Boom. Is that the only pair? Or did you do more than 2? Oh, wow. How many different ways can you make 12/15 adding together fractions? On the right-hand side, there's an example of an empty box. This is from Can Do Fractions. So again, that idea, that top one, how many different solutions for that top one can you think of? What about the bottom one? Oh, wow. What could the denominators be? What if I restrict how many digits you can use? So all of a sudden I've got one problem with many solutions to grapple with. And that's what I want you to talk about. If I was going to do the expanding brackets one, and this is one I did with year 8, if you look at the top, let's call those the standard questions, A, B, C, D. Well, D maybe, I don't know. Is D non-standard? Is that what it's also? I don't know. But, oh, wait a minute. H looks interesting. So even in that do it, and this is another bit of, I guess, a caution that I don't want students to say, oh no, you just do the solve it, you just do the do it, you just do the twist it. no, actually, I want everyone to go on this journey. And if they get it, fine. He won't hold them back. They'll get this and they'll be able to do it really quickly. I'm not giving you 27 do-its to do. I'm giving you just a few focus ones. In the secure it, I call it secure it, not twist it. Secure it, I want you to tell me what the mistake is. And circle it. Go on, circle where that mistake is, and then tell me what's happened, conceptually why that's not correct. Deepen it, again, I'm just giving examples of empty box to expose the structure. That's what empty box does for me. I love empty box. But I like the purple one better. Again, go on then, play with it. Over to you. Solve it one way, solve it in several ways. How many different solutions are there? If you're only allowed to use the digits once only. So hopefully, there's less is more here, and some people, I hope this comes across. I hope it fits the bracket of what people call intelligent practice. Questions to make you think. I'm not giving you 27,000 brackets to expand. However, there may be a place for that deliberate mechanical repetition to really hardwire I can do this skill, and I'll talk about that later. But in the lesson, I'm not going to spend lots of lesson time doing lots and lots of very similar questions, you giving me the answer. I want to get some bumps in the road. And I guess this leads to my caution bit a wee bit, is that I've just talked about the do it, secure it, deepen it, the tasks I want the students to do. And I think what's really important, and I know where this has gone wrong, some people, just give that out almost. And it's really important that we have a bit of a learning together moment. What is today about? What's the language? STEM sentence, some people call it. What representations? How do I want you to understand this? How do I teach it? So I do want to talk about this teach it, practice it. And that's something I'm very passionate about. And you'll see from the blog. Do it, twist it, solve it. Do it, secure it, deepen it. Do it, zap it, kick it. I actually think there's more words. This is about how do we teach it, practice it, then do it, secure it, deepen it, and then how do we review the learning at the end of the lesson. So actually, I think there's 6 phases. Not a snappier workshop title, but actually it's really important. So, oh yeah, that's interesting. None of this works, by the way, if I'm not clear about the kite I'm flying today. What's the key learning point? What is the thing I do want to secure and deepen? And if that's too broad, and I'll talk about that later, then this is almost impossible to do. I'm really tight on what I want you to learn about today. So in this case, well, let's do the journey. And yeah, okay, it's for secondary colleagues, you may be looking at going, oh, really? Well, this is a year 3 introducing adding fractions. So we've got a chocolate bar here. Colin's got 2 pieces, Coco's got 1 piece. What fraction of the chocolate bar are they eating all together? Over to you. And I'll just get loads of answers from the children. And I don't care if it's right or wrong. I want to know what's in your heads. And I think that's important. That's another principle of do it, twist it, solve it. It's just trying to say, are we okay? What are you really thinking? It feels like you're thinking the right thing, but are you really thinking the right thing? So let's put a speed bump in the road. So my job then now is there's a hook, get the students talking. And then to say, okay, so what does that look like? What does 2/5? Oh, 2/5 means 2 of 5 equal parts. 1/5 means 1 of 5 equal parts. So altogether, I can see I've got 3 of 5 equal parts. I've got 3/5. Oh, wow. So the fraction is 3/5. Cool. Children, there's a great question. My good colleague Liz Hopkins' favorite question. What do you notice? Oh, what I notice is the denominator stayed the same. But when you add fractions with the same, you seem to add the numerators. Boom, we've established the learning. The STEM sentence. Let's do another one now. Let's do that one. What do you think the answer is, children? Mini whiteboards. Oh, it's 5. Why is it 5, 6? Because when you add fractions with the same denominator, you add the numerators. Oh, do I need to do another one? I don't know. But I might have to do another one and another one. I'm doing my AFL now. I'm the responsive teacher right now. And it may be that some have got it. Go on and off you go, guys, and some haven't. But really, this is where I've established the learning, established the language I want you to use. So now we can have a go. Here are your questions that do it, secure it, deepen it. So those questions I showed earlier, have now make sense. And hopefully, certainly, the first two on the left-hand side, everybody has immediate success. A can-do feel, a can-do success. And hopefully with the other ones, because we've practiced together, we've established that learning. And then hopefully everybody gets to this point. Does everyone get to this point? I don't know. I don't know until the learning happens. And I think that's really important. Previously high attainers, the wheels may come off at this point. Previously low attainers surprise me. Different people surprise me at different times. There's no ceiling. Everyone's got the opportunity today to to secure and deepen their understanding. So let's talk about what do those teach it, practice, review it look like maybe for that other lesson. So here's another example. My key learning point, I'm multiplying a single term over the bracket, but actually I'm really interested in this first lesson about if that's a number. And maybe my next lesson if it's a variable, and my next lesson maybe if it's a combination. And I think that's important, that before I've done this lesson, I've mapped out my 3 or 4 lessons. And that's why as Kangaroo Maths, we're absolutely passionate about a 5-year journey, secondary, or even an 11-year journey, stage 1 to stage 11, 11-year journey. That's what we have on Kangaroo Maths because we're passionate. I don't know if we haven't got a coherent curriculum lasting, a macro design over 5 years. I haven't got the confidence that I can break this down into such a small step at this point. And that's really important. So that macro design gives me the confidence. I'm just using this example as well, by the way, because this was the lesson and we wanted to explore not algebra tiles, but the use of Cuisenaire to just expose the structure of this. And the students had to make that. And they had to make that. And I've used the bar model on the previous example. And why I just wanted to share that is all these big ideas of mathematics come together of teaching mathematics. And you might be looking at this going, Steve, come on, really? G equals green, Y equals yellow. But that was just the starting point of this. And then when I got to this one, it was, go on, you've got your Cuisenaires, represent it. Show me what you think that makes. And why I'm saying that, so some people did that and some people did that. And what was really interesting for me, I'm just talking now about the use of representations, I guess. This, going back to this one, Louis said to me, oh, wow, 3G add 12. Oh, wow, 3G add 12 is 15G. So I think the answer is 15G. And he's like, how could it be 15G? And if I didn't have the Cuisenaire there for him to see the mathematics, I don't think I'd have been able to answer that question. That exposed a misunderstanding I wasn't expecting. But this lesson was about them actually doing that together. So they then realized, oh, wow, I noticed something here. I can generalize that to expand a bracket means to multiply each term inside the bracket by the term outside the bracket. That's from the PD materials, the secondary PD materials. And I want everyone to be using that language. So when we have a go at one together, maybe I want to use a distributive law to explore this, but the students are saying it's this answer because I've multiplied each term in the bracket by the term outside the bracket. It's there at the bottom. I don't know if I'm doing free worked examples with them. It depends. But this one's interesting. Okay, that might offer something different. And by this point again, hopefully, they can now have a good go at these questions and hopefully have immediate success. Certainly in ABC, everyone can have immediate success. So I wanted to show those 2 examples because hopefully it fits also with this, which I think is really important. Mike asked you and used a lot on the Teaching for Mastery program, the idea that we're talking about here about careful choice of questions, what we want to vary, what we want the students to notice, not a variety. It's not just a pick and mix loads of stuff. And that's the important thing for the do it, twist it, solve it. The principles are the do it. I've got the what it is, what it's also. The twist it has got the what it's not, and the solve it has got here's some problems. And each one of those has been carefully chosen because I want the students to notice something. And if they stop noticing, and if it's not adding any value, then I don't give the question. So this is really important for me because not variation, not variety, because every time there's a question, I want them to notice, oh, that's another example of that. I can do it. Oh, That's like the last one, but it's got a 2 there. Does that matter? No, it doesn't, because I multiply each term inside the bracket. So that's very, very important for me. And I'm sure you're aware, and I'm just putting it up there as an advert, the PD materials and also on the Teaching for Mastery website, the 5 big ideas on the Maths Hub website. They talk about variation. I'm talking about coherence. I've mentioned some big ideas of teaching mathematics here. And if you're not aware of those documents, I find them really, really useful. And so coherence, representation, variation, mathematical thinking, and so on are useful to just have a conversation about how we teach mathematics. So to summarize, you know, that the can you do it, is about that. Give me the answer. The secure it and twist it is about using the non-example. The non-example to expose if a student understands. Dave Bowman, a good colleague of my Maths for UK PLC, is he's teacher initiated mistake. That's what he calls that. Yeah, I thought about it, and I'm going to put it in there. And if they do understand it, they'll get over the bump on the road. And if they don't, then they don't understand it. The deepen it has got problems to solve. Apply. Go on, off you go. Play. You'll see a big black dotted line down the middle there. And the reason why I'm doing that is because this is not about a race to the pink. What this is about is definitely the left-hand side is what I want the lesson to be about. And you'll notice at the bottom, by the way, there's a blue arrow saying, at every opportunity, at every point of the lesson, pupils have a chance to describe, explain, justify, convince, prove. That isn't just that behavior, mathematical behavior is not reserved for one of the boxes. So what's my caution? You know, hopefully you've got something from that. My caution is I try and distill this down to 4 things. And you see it spells kite cheesily on the left-hand side. The key learning point, intelligent practice, the answer's only beginning, use of examples and non-examples. That's for me at the heart of this lesson design I've been talking about. And it's the top one that I guess is the most caution. Because as I mentioned, Kangaroo Maths, a macro design over 5 years, well, 11 years actually. Same with the Can-Do Maths for primary colleagues. And I guess I'm just a little bit concerned. Hey, Ofsted, what's Ofsted here for? Well, you know, I do like, it's not often Steve will say this, I do like in the new framework that they talk about manageable steps. And I guess that's my caution, actually, is a small step is not a small step just because it's called a small step. If it doesn't feel manageable for the learner, and if it doesn't feel manageable for the teacher, if you're ever in the position thinking, how am I going to do this and this and this? How am I going to add fractions with the same denominator, multiples, not multiples? There's too much. So therefore, less is more. Less is more. So you know, it also talks about reasoning and solving problems and use of misunderstandings. And so it's really nice when the framework came out, because I was reading the maths section going, yeah, that's the lesson design I'm talking about. So we're not doing it for Ofsted, but it's nice that Ofsted have now joined the party. It's great. So I guess that's my caution, really. Just because something's called a small step doesn't mean it's a small step. So, I don't know if this works. You know, I'm telling you, this is an elephant. So therefore, it's an elephant. No, it's not. So rhino. That's an elephant. I'm joking. So this idea of mapping out the journey onto key learning points and making sure each one is manageable. Now, the danger with this, and I'm really passionate about this, this is not about atomizing the curriculum. This is not about isolated learning and the students don't make connections. They are connected, but the idea is the spotlight at each one, and by the time we get to maybe the 4th one, we begin to make more connections with what we've been doing. But if I try and do too much too soon, then I cannot get a secure and deep understanding as a learner. So I've been talking about, the other thing is caution here, is you may be by this point going, that's lovely, Steve, but actually we do know students need to do lots of practice. And I guess I'm just want to advertise this idea and just pick up this idea of I'm seeing practice in two ways. The maths lesson is about intelligent practice. We linger longer on something and to secure that understanding. That's to do it, secure it, deepen it, design. Those questions are put together to try and deepen and secure your understanding. I might then, and primary colleagues have a separate session in the day. They call it a maths on track meeting in most schools I work with. And that is not about new learning. That's about practice, practice, practice. I know some secondary schools that I work with, that they, that's what homework is now. Homework is about deliberate practice to hardwire the learning we've done in the lesson. It's not new learning. It's not pushing you further. That's where, like a sportsman, we just get stronger and stronger and stronger. Use it or lose it, Dave Bowman talks about. And that's so if you were thinking, oh, Don, this do it, twist it, solve it, that's not enough though. Well, it's not for that. What it's for is to secure and deepen understanding of something today. Yes, we'll need to do more practice. And I guess, differentiation's always asked, and I've shared this off Twitter. What I'm trying to demonstrate with it as well is there's a high expectation. Today's key learning is this. We expect everyone to get there. The question is to what depth? Well, we don't know until the lesson happens. But that's how I think support and challenge. And I support you through the start of the lesson, and we use the representations to secure your understanding. And then you can show me you understand the maths today, and I will then challenge you with the secure and the deepen it. I will put speed bumps in the road. I mentioned earlier, Ready, Set, Go, the Just Maths team, Justaroo, Kangaroo and Just Maths coming together. And there you go, a whole load of questions. If you're thinking, where can I get these? Then that's coming out soon. And you'll notice there's the Pythag in the bottom left. We've got the adding fractions on the right-hand side. This revision guide, study book, whatever this thing is, has just got loads of these. That top one, that translation, I don't know if you've got students who do that they will, why, it's very subtle, isn't it? Because it's saying, let me see if I can do this with the pen, that actually if I count 1, 2, 3, 4, and then go 1, 2, then I do get from that corner to that corner. It does seem to work. Oh, but actually it's not corresponding corners. So actually I know students who happily do that, and so that's why that could be a correct response. I'll stop doodling on the screen because it just makes it a mess. So I hope that was of use, maybe to try and bring it together. What am I trying to say? Do it, twist it, solve it. I hope have a go. Have a go. It works wonders. The teacher has a better time in the lesson. I have a better time in the lesson, and the students seem to respond. And what I love is different students surprise you. But it's really important that if I'm trying to do too much, so it's back to the curriculum design, to teach less, learn more is a really important mantra for me. That links with linger longer. I've got the confidence today to just linger longer on this. And if you feel stressed by your curriculum, then can I suggest have a good look at it and think about that 5-year journey. If I'm thinking about a 2-year Key Stage 3 and a 3-year Key Stage 4, vice versa, that's not a coherent curriculum design. And therefore, I know colleagues who feel pressured. I work with trainee teachers, and I know they feel pressured sometimes. They've got to cover stuff, but that doesn't lead to understanding. I guess the what it is, what it's not, that's what I hold on to. The twist it is about what it's not. I am twisting your understanding. I'm trying to see if you really do understand this thing today. I know some places they go, oh, we have fluency, reasoning, problem solving. So reasoning is our twist it. No. Because we reason all lesson. That behavior is part of being a mathematician. So it's not just about any old reasoning activity. It's about a mistake to say, do you understand today's learning? Teach up, keep up is an important mantra for me. The answer's only the beginning. That's a really important principle at every point of the journey of the do it, twist it, solve it lesson design. If you give me the answer, convince me. Give me the answer, convince me, using the right language. And depth over speed. I'm not interested in cracking through stuff. A surface level. The do it, twist it, solve it, do it, secure it, deepen it. He's saying, great, you can do it. Go on then. Let's see some progress in terms of the depth of your understanding, not just superficially onto some new content. So I hope that helps. This, you can find this on the blog if you want to reference it, if you want to explore with it. I have done this version, which doesn't look as nice, I admit, but I just wanted to advertise this idea that the do it, secure it, deepen it. Some people say, is that where I do reasoning? Is that where I do reasoning? Reasoning is where is the whole lesson. So I want students explaining, describing, justifying all the time, and that's just something that I've come across over the years. If that's not happening, if it's just about giving the answer, then that's not embracing the principles of this lesson design. So thanks for joining my workshop. I hope you found the do it, twist it, solve it idea interesting. Keep hold of those principles, and you'll have a great time with your students. Thanks very much for your time, and thanks for coming to my workshop.